On this graph, the x-axis represents time and the y-axis represents distance. To get the lines between each point, y equals the distance between the 2 points of y divided by the distance between the 2 points of x. For example, the distance between 0 and 20 is 20, so I'll divide that by the distance between 0 and 30, which is 30. Now the equation is multiplied by x and added to it or subtracted is whatever the number is going to make the line move up or down in order to cross through the 2 points. To find it will involve playing around a bit with the numbers. After that, to confine the line between the 2 points, put it in parentheses. X is greater than the previous number that is x, but less than the next number that is x. For example, x is greater than 0, but x is less than 30. And that is how to graph the distance and time separately. To find the whole trip, do the same steps, but with the first and last points together.
For Mr. Paisley's trip back, I used the same method as his trip there, but using the data from his return trip. Again, the x-axis is time and the y-axis is distance. From this data, we can deduce certain information about his trip. For example, the start of his trip to the next stop, he traveled only 40 miles in 240 minutes. This means he was most likely in traffic at the time. However, after that, his speed seemed to increase and stay mostly the same for the rest of the trip. Assuming he went a consistent speed between stops, his speed averaged 41 miles per hour after his first stop.
Hi, my name is Denna and my slide shows the graphs for fuel tracking as well as the mileage from Napa to Oregon and Oregon back to Napa. The x-axis indicates the distance traveled while the y-axis shows the fuel tank tracker. The maximum gallons of fuel the car would have at full capacity was 36 gallons, so that is the maximum height on the y-axis. I calculated the distance by taking the odometer count from the start of each drive, from leaving his house in Napa and leaving the hotel in Oregon, and with every single stop he made, I would subtract the original odometer number from the new one, giving me the exact distance he traveled since the beginning of his trip. Whenever he was driving for very long distances, it was easy to tell because his odometer number would drastically increase and his fuel number would drastically deplete. Whenever it was just a short little trip, the odometer would barely rise and the fuel would hardly ever deplete.
Here I have created a vector map to show Mr. Paisley's journey from Napa, California to Corvallis, Oregon. I have also shown his trip back from Corvallis, Oregon to Napa, California. My first step was to record the latitude and longitude of each stop. I did this by putting each location into Google Maps and then finding the latitude and longitude in the web address. Next, I subtracted each set of coordinates from Napa's coordinates and made Napa's coordinates equals to 0, 0. I did this because I wanted Napa to be at this very center of my map. Next, I switched my graph into degrees because I felt it would better represent vectors. And then, because 0 through 90 degrees was in the first quadrant of my graph, I made the x-axis north and south, and I made the y-axis east and west. I then made all of my coordinates positive in order to move them all into the first quadrant of my graph to suit this new change. My last two steps involved labeling each point by making the individual point a separate item in Desmos, and then just checking the label box and naming it. And I also connected all of the points on one trip by going into the settings and switching the tables from isolated points to connected points. Although this graph was, in the end, pretty simple to make, it took a lot of figuring out, and I've learned a lot from the experience. That concludes my creation of the vector map on Desmos. Once I was done creating my graph, I had to move on to calculating the actual vectors. For each vector, I calculated the angle and the distance in almost exactly the same way. First, I found the difference between point A and point B, both in longitude and latitude. Next, I used a calculator online to transfer my longitude and latitude into miles. I did this because I realized that you can't take longitude and latitude and combine them into a diagonal line. Once I had all my numbers in miles, I drew a triangle and labeled my sides accordingly. Next, I used the law of cosine to find my missing angle. First, I divided the adjacent line by the hypotenuse. I then found the arc cosine of this number. In some cases, I added 90 degrees based on whether or not the angle was going past 90 degrees. I then wrote out my conclusion as so. Stop A to stop B, number of miles, number of degrees west or east of north. When I first did all of my calculations, I calculated my angle relative to Napa rather than relative to north. I then realized my mistake and realized how inconvenient it would be if I was going from, say, Corvallis to Napa and I had to calculate how many degrees I was from Napa. That is how I created my vector map from Napa, California to Corvallis, Oregon, and from Corvallis, Oregon back to Napa. Thank you.